Hi everyone. In this video, we are going to solve a problem. The problem name is merge case sorted list and the problem number is 23. Alright. So guys, this video is going to contain three parts. In the first part, we are going to clearly understand what this problem says. In second part, we are going to see the logic part. We are going to discuss about how we can solve this particular problem. In the third part, what we are going to do, we are going to implement our logic in C++, Java and Python programming language. Alright. So now let's move to the first part. Let's understand this problem clearly. So problem says you are given an array of key linked list. The name of the array is list. Each linked list is sorted in ascending order. Alright. Merge all the linked lists into one sorted list and return that particular linked list. So I hope now guys you understood this. Let's understand this with example one. Then we will have a better idea. So guys, we are given with some linked list array, right? So let's say there is an array with the name of list. Fine. And this contain nothing but some linked list. So the first linked list is if it is a first linked list, so this is nothing but it's look like this 1, 4, and 5. And the second linked list, I would say, let me change the color. So second linked list is 1, 3, and 4. All right. And the third linked list is nothing but we could say 2 and 6, right? So these are nothing but three linked lists, and these are given in our array. So in our array is going to contain one head of a linked list, second also, and third also, right? So this is our array. Now what do we have to do? We have to make only one linked list. So we have to make, if I take another color, so we have to combine these three linked lists into one linked list such that that combined linked list is nothing but assorted. So the resultant would be nothing but 1, then again 1, then we can say 2, then we can say 3, then we can say 4, after that again 4, then 5, and at the end we are going to have 6. So this is nothing but we can say this is the combination of all the nodes, and this is also in a sorted order. You can see in increasing order. I hope this makes sense, right? So how we can do this? What are the going to be steps? What logic we are going to use? Definitely we are going to discuss it. But first of all, you should have a better idea. Do you have a clear understanding of this particular problem? If yes, then let's move to the next part and see how we can solve this particular problem. What should be the logic, right? So one thing is clear that we have all the linked lists in sorted order already, right? All right. So now, guys, I'm going to discuss about the logic part, and let me just scroll it down. So guys, logic part is going to be very easy. If you will focus it clearly, then logic part is going to be really easy. See guys, the things we are given, just focus over here. So we are given a sorted linked list, right? And I hope guys you have done, let me tell you first of all, we are going to discuss about two logic, right? First logic is going to be really very easy. Second logic is going to be not that much easy, but it's going to be very efficient, right? So the first logic we can say implement, we can say we are going to use implementation of two sorted linked list. Implementation of two sorted linked list. So how this is going to work? Let me tell you. So guys, forget about merge case sorted linked list. Just think about this. You have only two linked list, right? And just that two linked lists are in sorted order. Just you have to merge them. So can you do this? Definitely you can do this, right? If you know, you can easily do it. If you still know, then let me tell you how you can do this. So let's say this is a first linked list. So I'm going to take this thing. So 1, then 4, and then 5, and the another one is 1, 3, and 4. So if you have only two linked lists, then you can easily merge it, right? You can just compare. You can give a name L1, you can give it a name L2, right? And resultant you can say new linked list, so you can say L. So you are going to compare. If L1 dot value is less than L2 dot value, then make this particular one node here and move ahead, right? So you can see here both are same, so you can take any node, and let's say you took L1 node and L1 is coming over here, right? Now you're going to compare with this particular node and 4. So one is already smaller, right? So one will come here and L2 will come here, right? Now which one is smaller? 3 is smaller, so L3 node will come here and L2 will move from here and it will come over here. Okay, now 4 and 4, which one is smaller? Both are we can same. So I took L1, so L1 will come here, right? So 4 will come here, and here L1 and L2, which one is smaller? 4 is smaller, 5 is greater, so 4 will come here, and L1 L2 will come out of bound, right? Out of one node we can see, it can say L2 is pointing to null now, right? So if it is pointing to null, we don't need to compare with that, right? So L1 is going to come over here. So this is how you can compare a two, we can see you can merge a two sorted linked list, right? So now we are given a case sorted linked list, but you can use same formula, isn't it? What you are going to do? You are going to say, I have a three linked list, no matter. First of all, I'm going to compare these two linked list. Then the resultant part is going to compare with this one. The resultant part is going to compare to the next one, and so on, right? So that thing you can solve it, right? So let me write here logic one. So this is nothing but logic one. Here, what we are going to do? We are going to say we are going to maintain a first node. So we can say the first linked list, right? First linked list. There is going to be nothing but resultant, right? So we can say result linked list is still none, right? so it is null. And we are going to traverse over the loop for I, we can say int I 0 to I less than length of that particular linked list, so let's say n, and I plus 1, right? So our link result is going to compare. You can say here I'm going to use a tool function merge two linked list, right? So I will make this function merge two linked list, and I'm going to pass this result comma list of I. So I can say list of I. So I'm going to pass it. This is going to give me the result of two sorted linked lists that will again store the result in the next iteration. I'm going to compare this. I'm going to sort this result with the next part of the linked list, and so on up to this. Once this loop will over, we are going to have our return result, right? And this merge to linked list function, I hope you got it. How you can do this? You can use the same logic, right? So this is nothing but merge to linked list function, right? So this was the logic one. I hope this you are getting it. Now we are going to move to the logic two, which is going to be really, we can say, not that much hard. We don't need to add an extra function. We can do in the same function only, right? So what is this function? So let's move to the logic two. So guys, here logic two. So guys, logic two is going to be really easy. You can see that if just what we need to do, we need to find out the minimum value in all the linked lists. I hope you are getting it. So minimum value is one here, here one, here two. So which is the minimum value? We can say this one, right? So we are going to mean, we can say the move this, we are going to delete this particular pointer, right? So in our linked list, we have 1, 1, 2, right? We are only having a head pointer. I hope we are getting it. The first one is smaller. So we are going to move it, and we are going to say this one dot next is to contain a 4. If you're not getting it, so let me come to this particular part below and let me explain it clearly, because this is going to be very, we can say, important for you in interview purpose as well. So we have 145, 134, and 26. So let me say 145, 134, and 26, right? All right. So now what am I going to do? I'm going to say this is 1, and this is again 1, and this is 2, right? So this is stored in our list array. I hope you know this. So we are only having a header, right? So head of a linked list. Now compare with these things. Which one is smaller? So let's assume this one is smaller because both have same value, 1, 1, and 1. So one is smaller. I'm taking this. So I'm going to say in my result, this is my resultant linked list. So let me maintain it with a different color. Sorry. So I'm going to maintain it with a different color. So let's say this is result. Fine. So in result, I am going to say I am taking of 1, right? 1 is smaller. And what I'm going to do in this part, I'm going to move it 1 to, I'm going to store here the next part of it. So this was first linked list. So 1 next is 4. So I'm going to store it here 4. And this will remain same. Fine. And here, now which one is smaller? This one is smaller. So I'm going to say result is going to be nothing but 1. So let me take a different color. So this is going to be nothing but 1. I have this making a sense. And this is going to store the next part of linked list. So 4. One next part is, you can see 3. So it's going to come 3, and in 2 will remain same, right? Okay. So let me remove result here and let me take it here. Here it was 1, then it was 1. Now which one is smaller, 4, 3, or 2? You can see that 2 is smaller. So 2 will come here, and 2 will store the next part of its linked list. So 4, 3, and 2 is nothing but, and 2 next is 6, right? So 6 will come over here. Now which one is smaller, 4, 3, and 6? 3 is smaller. So 3 will come here, and 3 will store the next part of it, right? So we can say 4, and 3 next is 4, and then 6, right? So now which one is smaller, 4, right? So 4 is going to come here, and 4 is going to store the next part of it. So let me take a different color, and here 4 next is nothing but 5, then 4, then 6. Now which one is smaller? Again 4 is smaller, so it's going to say the 4 is the next part, and the 4 will going to contain the next part of it, and you can see that there is nothing, right? So there is no next part of 4. You can see in the second English, after 4 we have nothing. So we're going to say 5 comma null, then 6. Now which one is smaller? 5 is smaller, so I'm going to say 5, and 5 will move to the next part. So next part, you can see also 5 next is nothing, null. So we're going to say null, and null, and then 6. And now there is only one element, so 6 will gonna come after 5, right? So we are going to return this particular result. I hope we are getting this particular part, how we are going to do this. This was the logic, right? Here we don't need to include our implementation part. Just I have told you the logic, how this is going to work. Now it's matter that which programming language you choose, right? That's why I told you this logic, because if you are using a JavaScript, which I'm not going to cover, then you can easily do with your programming language if you know the logic part, right? But in this video, we are going to use a 3 different programming language: C++, Java, and Python. If you know any of this programming language, then you can easily follow this particular video. So now let's move to the implementation part and implement our logic in, first of all, with Python, then move to the C++, then Java, right? So in Python, first of all, what I'm going to do, I'm going to say, let's give a min value, so which is going to contain initially max value. So we can say float infinity Then what I'm going to do, I'm going to say the index. Initially it is -1. Now I'm going to traverse over the linked list and I'm going to get the minimum value, right? Which we were doing. So for int note here, I can't do this thing. So I'm going to say for I in range of, I can say length of linked list, right? Or lights, and I am going to compare if list of I. First of all, I'm going to check it. If it is null, if it is none, then what I can say, I don't need to do anything. I can say continue over here only, right? We don't need to compare with that value, particular value. But if it is not null, then compare it. If list of I is, we can say less than min value, right? If it is less than that particular value, then what we can say, we can say our index should be equal to that particular I and min value should be equal to list of I. Lists of I have a dot value, right? So we need to compare this is a node. We can't compare with that. We need to take the value, right? Dot value. I hope this is making a sense, right? Once this is done, so we are come out from the loop and we are going to check it. If index is 1, -1 means we haven't got any single value, then we are going to simply return none, right? But if it is not a -1, then what we are going to do, we are going to say, all right, so we are going to create a node. We are going to say node is going to be list of I dx, and this next is going to be nothing but we can say, but before doing a next part, we are going to say list of idx is should contain its next value, right? List of idx dot next, right? So we can say it should contain its next value. Fine. And node dot next is going to be called the same function again, merge k list, and here you can pass in this function list. I hope this making a sense. And then we are going to return our node. So this was a simple logic which we are going to do. This is not a hard problem, I would say. This is just 4 level of we can say 5 or 6 line of code, and you can see all the test cases are also passed. So let's try to submit this particular code. And it's taking a bit time, so let's see what's gonna happen. You can see that it's totally get accepted, right? So we have successfully submitted our solution, right? I hope this making a sense. So now let's move to the next programming language, that is nothing but C++. And same logic which we are gonna do is nothing but, first of all, we are gonna maintain a min value. So min value is gonna be nothing but int max right now, and then int idx which is equal to -1. So I'm going to do a bit fast here. So here what I can say, I'm going to traverse over the loop for int I0 I less than list dot size, and I can say I plus plus. Okay, and here what I'm going to say, first of all check it if list of I is null ptr, then what you can say continue here, right? But if it is not the case, then you have to compare with that value. So lists of I slash val, if it is less than min val, then what you're going to say min val should be equal to list of I val, and here you can say nothing but idx should be equal to this particular I. So once this part, let me say I, once this part is done, we are going to check it. If idx is equal to -1, then what I can say, return null, right? But if it is not a -1, that means there is a value, right? We got a minimum value. So we are going to make a node. So we are going to say list node. Let me write a list node, and here you can see node, and here it's going to be new, or we can say nothing but list of I, right? So we can say list of idx. This is nothing what we want. And what I can say, list of idx should contain now list of idx next part, right? Once this is done, we are going to say node next part should be the same function. I'm going to call merge k list, and here I'm going to pass a list, and I'm going to return our node. So let's try to run this code and see whether it's working fine or not. And I got an error return, right? I have to use n total particular words. So let's run this code now. And you can see that all the test cases are passed. So let's submit this particular code as well. And here we go, guys, right? So we have successfully submitted this particular code. Now let's move to the last programming language, that is nothing but Java. Fine. So here what I'm going to do, I'm going to say int, and here I can say min value, which is going to be nothing but integer. So let me write here integer dot max value. All right. And after that int idx, which is going to be nothing but -1. Let me write -1. Then our traversing over this for int I0, I less than list dot. So what I can say list of length, right? And I plus plus, right? So I'm going to say if list of I is equal to null, then what you can say, you can return, not return, you can say continue. We don't want to take that particular value. But if it is not null, then check compare. If list of I val is less than min val, then what you can say, min val should be equal to list of I dot val, and idx should be equal to this particular I, right? Now we are going to compare it. If idx is equal to -1, then return just simply null. But if it is not a -1, then what you can say, let's create a node. So we're going to create a node, list node, and here node, the name of node, we can say our node is node only, and here we are going to say list of I. idx, right? And list of idx now gonna contain the next part of it. So list of idx dot next. Now this is done, so we're going to call the same function for node next part. Node next part should be, we can say merge k list, and here we're going to pass our list, and we're going to return our node. I hope this making a sense, right? So if this is making a sense, let's try to run this code and see whether we are getting a right output or not, or we are getting any error. Now you can see that all the test cases are passed. So let's try to submit this code as well. And believe me guys, I never thought that the hard problem will be that much easy, right? So you can see that all the test cases are passed, and we have successfully submitted with Java code as well, C++ code as well, and Python code as well, right? If you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.